Alright guys, let's get started with our guided notes on the tsunami. So, begin with getting your aim. What are the causes and effects of tsunamis? So, as we're going through the notes guys, pause the video as needed for you to make notes. So, let us begin. Alright, so did you know that the word tsunami actually comes from the Japanese term harbor wave? So if you look at how it is written in Japanese, su is written this way, that means harbor, nami would be wave. So put these together, harbor wave. All right, so let's review what a tsunami is. A tsunami is simply a series of traveling waves that have an extremely long wavelength and time period. All right. So they're generated when an entire column of water is suddenly moved vertically, such as the occurrence of a great earthquake. All right, so let's get into what's up with tsunamis and why they're so dangerous. Well, one of the biggest things is the velocity at which these tsunamis travel. A tsunami can travel well over 960 kilometers an hour, or almost 600 miles an hour in the open ocean. So that's as fast as a jet flies. So if you look, we have commercial jets clocking 800 kilometers per hour. So tsunamis can go faster than jets. So it can only take a few hours for a tsunami to travel across an entire ocean. All right, and a regular wave, which is generated by wind, can reach speeds up to 55 miles an hour. So tsunamis are much, much faster than their regular wave counterparts. All right, so this is just an animation showing what happens to the wave as it enters shallow water. So if you look at the animation there at the top, when the wave enters shallow water, it slows down and its amplitude increases. The wave further slows and amplifies as it hits land. So notice how the wavelength is very spread out, but as it gets closer to the land and the land gets shallow, it amplifies. Notice how the wavelength gets less in between the waves at this point. All right, so this is just a little graphic on the tsunami. And again, it breaks apart what you saw last time in the little graphic and asks you some information. So answer the questions when they pop up. All right, so characteristics of tsunamis. So just some of this we've already mentioned. So they move at very high speeds. They can travel enormous distances with very little energy loss. So in other words, if the tsunami started at Hawaii, more than likely it's still going to be big enough to cause damage when it crosses the ocean and hits California, or even Japan, which is on the other side of the world. So this can cause damage thousands of miles from its origin. So meaning if the tsunami happened or began in one area, even if it travels a very long distance, it can still create havoc. All right, it can be several hours between the creation of a tsunami and the impact on a coast. Again, it can cross entire oceans. All right, so how are tsunamis generated? Well, they're primarily caused by underwater earthquakes, which again are the most common cause. So these are seismic events that displace a large volume of water, again by shifting the ground, which generates waves that travel across the ocean. Other ways this can happen would be underwater landslides, volcanic eruptions, or meteor impacts. All right, so volcanic eruptions are less common because these generally cause the volcano to collapse, which will generate a tsunami, but they're not that large generally. And meteorite impacts are rare simply because our atmosphere causes most meteors to disintegrate before they reach the ground. All right. Warning systems. So there's lots of warning systems that we're working on developing to make our coastal cities safer, but it's an ongoing effort. So modern technologies have greatly improved tsunami detection and warning system. Some key components include seismographs, which are digital instruments to detect and measure the strength of earthquakes. This is often the first indication of an actual tsunami. You also have tsunami buoys that are deployed throughout the ocean. So these buoys detect changes in sea levels and may indicate a tsunami is on its way. And then you have coastal sirens. So these are simply sirens that alert people that a tsunami is an imminent threat, giving them time to evacuate. All right, so here's just a little graphic illustrating the tsunami buoy system. So if the buoy goes up, it can measure how high it goes up, and then it relays this information to satellites. All right, so signs of an incoming tsunami. The biggest and the most obvious thing is you're going to see the water recede quickly at a beach. So all of a sudden you're looking out at the ocean, and all of the water starts to go out further down the beach toward the ocean. So this is known as drawback, and this is going to be like, hey, you need to run. All right, so also if you're on the coast and there's an earthquake, it may have also caused the tsunami. So if you feel an earthquake and you're near the ocean, you should get to higher ground or go further inland. All right, so some beaches have tsunami sirens. These are generally going to be on the west coast or on islands. So if you hear them, do not ignore them. So, and this is often something that catches a lot of people off guard. The first wave of the tsunami is often not the largest. So the first wave may not be the only wave. So if you get through the first wave, you need to get inland quickly, because there often could be bigger waves on the way. All right, effects of tsunamis. Pretty much, guys, it's pretty straightforward. Tsunamis are really powerful events, and they are devastating if we cannot prepare for them. So, loss of human life. So, especially if this happens in populated cities, it's hard to avoid a large wall of water. So, destruction of property. These waves are massive and can destroy buildings, damage infrastructure, and change natural landscapes. All right, it can spread disease. And this is mainly the aftermath. So it's easy for waterborne diseases to be spread due to water contamination. And then you have the destruction of entire ecosystems, because they can literally take away most of the plant life in an area, or any life that is like a terrestrial animal that is on the ground. If it can't get away, it will be destroyed. All right. So here's an illustration showing what happened when there was an earthquake back in 2004 in the Indian Ocean. So this was an undersea earthquake, and its magnitude was measured as 9.0. So you can see here the origin, where it happened, and how far the tsunami traveled. Again, the time is sped up here, but again, that's hundreds or even a few thousand miles. All right. So this is based on the earthquake we just saw there. So notice the epicenter was 150 kilometers west of the coast of Sumatra, and all of the cities and coast affected are these. So even the coast here was affected, because again, the water can literally travel over large land masses. So the earthquake we just talked about came just 3 days after a magnitude 8.1 earthquake in an uninhabited region west of New Zealand. All right, so we think there are possible connections between the earthquakes, and it's possible of the seismic chain reaction across the neighboring plates has also been considered. All right, some more facts on this. The total energy released by a magnitude 9 earthquake exceeds the amount of energy consumed in the U.S. in 1 month. So if we were going to take that seismic energy and convert it into electricity, that's a lot of power. All right, so the massive release of energy and shift in landmass significantly altered Earth's rotation. So it literally affected the entire world. All right, so here's a picture showing you what a tsunami can do just based on the wave going over an area. So at the top, you see what an area looked like before the tsunami that happened on December 26, 2004, to that village in Indonesia. Before, it was pretty nice. It was big. After, the village is gone. All right, so It's important to understand tsunamis are not tidal waves. They do often resemble a tide that keeps rising, but rather than cresting waves when they reach the shore. Tides cause tidal waves, but tsunamis are generated by underwater earthquakes, or those other options that we reviewed earlier. All right, so is it possible to predict tsunamis? Well, we know the immediate cause of tsunamis, and these can be identified quickly since these are earthquakes, but predicting the exact time and impact of a tsunami remains very challenging. However, with warning systems in place, we aim to provide as much advance notice as possible to minimize loss of life and property. All right, so this is another interesting tidbit. Animals are often able to detect these events and run and get away from them. So there have been anecdotal reports of animals behaving unusually before tsunamis. These theories suggest that animals might sense the initial earthquake vibrations before humans do, or detect changes in the air or water pressure. However, relying on animal behavior is a problematic tool for tsunamis, and it is not scientifically proven or reliable. So, in conclusion, understanding the causes and effects of tsunamis, along with the importance of warning systems, can help mitigate the devastating impact of these natural disasters and what they can have. So, educating students on these topics not only raises awareness, but also prepares them for the understanding of complex natural phenomena and the importance of preparedness. All right, guys. So, be sure you've wrapped up your notes. If you need to rewind, feel free. Otherwise, have a good day.